Okay guys, in this section 11-4 we are looking specifically at quadratic sequences. And so a quadratic sequence would be a sequence that has a quadratic explicit formula. Alright? And so a quadratic sequence is also a sequence of numbers in which the second differences between the consecutive terms differ by the same amount, called a common second difference. So like for example, with this sequence right here that we have, 1, 2, 4, 7, and 11. Okay, so let's take a look at the difference between the terms. So there's 1, 2, difference here 3, and 4. All right, so one thing I want you to notice is the difference is not the same, right? The difference is not constant. So what that tells you is it's not arithmetic. All right, so that's what we learned about in the last few sections. Okay, so if the first term is not, or the first difference is not the same, go to the second difference. The difference between 2 and 1 is 1. 3 and 2 is 1. 4 and 3 is 1. So the second difference is constant. If the second difference is constant, then you have a quadratic sequence. All right, so that's how you can tell the difference between the different types of sequences is when is their constant difference? At what level is their difference constant, in other words? All right? And so here's the formula for finding the nth term of a quadratic sequence. All right? So here's the formula. And so this is the formula that would give you the explicit formula for that sequence, right? Okay, so D is the first difference. The first difference in this case would be 1, right? That's the first difference. All right? The constant difference would be the difference where it's constant. In this case, it's also the second difference, right? So constant means the same every time, and second difference is where it would be the same for a quadratic sequence. So C, the number for C, is the constant difference, or that second difference, right? Okay. Let's see. And then A sub 1 is your first term, which would be 1. Okay, so in this case, if we were using this sequence to find the explicit formula using this, then D, that first difference would be 1. Okay, the constant difference would be 1, and the first term would be 1. All three of those values would have a 1 plugging into it. Then simplify, and then that's your formula. All right? Now, you can use this formula to get the explicit expression, or you can actually use this method. All right, so when you've got a quadratic sequence, here's kind of what the events roll into. So if you've got A plus B plus C, right, so those constants, the sum of those three constants would be the first term, right? And so the second term, right, would be if you plugged in a 2. If I plugged in a 2 here, what would we get? 2 squared is 4, 4A, plus 2B plus C. And then the third term would be a 3 squared is 9A, 3 times B is 3B, and then plus C, and so on. So they're writing these terms in terms, in other words, of the constants A, B, and C. Well, what happens when I subtract these two? Well, when I subtract these two from each other, I get 3A plus B. So the first difference should equal to 3A plus B. The second number in the first difference should be 5A plus B. And then when I subtract these two together, the second difference, that second difference should be 2A. So what we can do is we can take, say, 2A, put it equal to what this number is, and solve for A. Then plug the A back in here, solve for B. Then plug A and B here and solve for C, and we can write the explicit formula that way as well. So you've got two ways that you can come up with the explicit formula for a quadratic sequence. You can either use this, or you can use these kind of as systems of equations to solve for your A, B, and C value, and then plug it back in here. All right, and so we'll do examples of each one of those, and you can kind of see how that works. All right, so the usefulness of this is to be able to come up with an expression for the sequence. All right, and I'll kind of talk about that in a minute. The next thing, here's the formula for the sum of a quadratic sequence. All right, and so again, here's the formula, right? N is the number of terms, D is the first difference, and C is the constant difference or difference of the difference. And so the second difference or the constant difference, since it's quadratic, and A is the first term. So A is there, the first term. All right, so we can use this formula to get the sum. So remember we had the formula for the sum of a arithmetic sequence. So this is the formula for the sum of a quadratic sequence. All right, so let's go ahead and look at the type of problems that we're going to be faced with. So the first one we come to, it says find the formula for the nth term. All right, so a lot of times when you come to patterns like this, you try to find it, and it's easy when the first difference is the same. It's arithmetic, and you can come up with the formula real quick. But when it comes to quadratic, it's a little bit tougher. So what's the difference here? 7. First of all, let's see what kind of sequence this is. 18 minus 7 is 11. 33 minus 18 is 15, and we have 19 here. All right, so it's definitely not arithmetic because the first difference is not the same. Let's go to the second difference, 4, 4, 4. So since the second difference is constant, we know it's quadratic. All right, so if it's quadratic, then we know that we have two methods that we can use to find the formula. All right, so the first method would be go back to that formula, right? And so when we go to plug in the formula, all right, so let's see what we've got. So for my formula, the first number is the first term. All right, so what's the first term? Well, the first term is 0. All right, then it's going to be plus. All right, let's see what else we got. D, so what's the value for D? The D is the first difference. D is the first difference. Well, the first difference is 7, so that's going to be 7. Then the formula is open in minus 1, all right, plus, all right, let's see what we have next. So after the n minus 1, we got c over 2, and c is the constant difference, right? And so the constant difference is 4, so that's going to be 4 over 2. I'll just write it in like that and simplify later. And in the parentheses, what have you got? N squared minus 3n plus 2. N squared minus 3n plus 2. All right? So we've plugged into the formula all of the parts that we need. And so now it's just a matter of simplifying. 0's gone. That's going to be 7n minus 7. Let's see, that's 2. So that would be plus 2n squared minus 6n plus 4. All right? So now I need to put the leading term here, the highest coefficient, or the highest power. That's 2n squared. Subtract those two, and then that would be plus n. And subtract that, and that would be minus 3. All right, so there's your formula. If you want to make sure that it's correct, you can just double check. Like, for example, the third term should be 18. 1, 2, 3. Let's plug 3 in here and see what we get. 3 squared is 9. 9 times 2 is 18. And then 3 minus 3 is 0. We get 18. If you wanted to double check the others, you could. But I'm pretty confident that that is the correct answer. All right? Now, remember, there was a second way that this could be done. You could also do that by using this method right here, right? And so let's see how it would work using this method with these common differences written out in terms of A, B, and C, an unknown A, B, and C. All right, so first of all, remember, we're trying to plug into this formula, right? A(n) squared plus b(n) plus c. And what I want to find here is I want to find the A, the B, and the C, so that I can actually plug it into the formula and come up with the right answer. Well, remember, this second difference is equal to 2a, right? The second difference is equal to 2a. So that means 2a equals to what? 2a equals to 4. Well, if 2a equals to 4, then I know a is equal to 2. All right, and I got 2. Got 2 for a. Okay, let's see if we can solve for b. So I'm going to go here, 3a plus b. Well, we already know a, right? So 3a plus b is going to be equal to this number, which is 7. So I need 3 times 2 plus b equals to 7, because I already know that a is 2. So that's going to be, let's see, that'd be 6, and then I subtract that from 7, so my b is equal to 1. Oops. B is equal to 1, so I got 1 there. And all I need now is C, and I can get that from this one. A plus B plus C equals to the first term. So that means A, 2 plus B, which is 1, plus C's got to be equal to my first term, which was 0. So all of that is going to be equal to 0. And then that's going to be 3. Bring that over, so my C is equal to negative 3. And so if C is negative 3, then I can write back out the formula. And so when I do, 2 goes here, 2n squared plus n minus 3. I get the same thing that I got when I used the other formula. Okay? And so, really both of them are about the same amount of work. You could use either one you like if you have one that you prefer. Either method, as you can see, gets us to the same response, the same answer. All right? So you've got your choice as to which method that you would like to use there. Okay? Let's see. We've got another one that we need to try to find the formula for. All right, so we've got from 8 to 8, that's 0. 8, 10 is 2, 4, and 6. So let's go again because it's not constant. So we got 2, 2, and 2. So now we know we have a quadratic sequence. Okay? So again, we can go back and use the same formula. Remember, a sub 1 is the first term. So my first term is going to be 8. So it'll be 8 plus, all right, what's next? The first difference. All right, so the first difference comes next there. First difference is 0. 0 times n minus 1. Close it off. Plus, okay, the next thing that I have is c over 2. C is the constant difference, which is my 2. So that would be 2 over 2. And then times n squared minus 3n plus 2. All right, so there we go. Simplifying this now, I'm going to have 8 plus, that is going to disappear, and that's times 1, so that's just going to drop straight out of there. N squared minus 3n plus 2. So I'm going to end up having n squared minus 3n plus 10. All right? Double check it with the terms if you feel like you possibly have made a mistake. 1, 2, 3, 4, 5. Let's check the fifth term. 5 squared is 25. 25 minus 15 is 10. 10 plus 10 is 20. And to make sure we're right, we should check all of them, but feel like that's sufficient enough to say that that's the right answer. All right. If you want to do it using the other method, you could. Remember, the task is to find the value of A, B, and C. So we'll just go through that method as well. So what's 2A equal to this time? Remember, 2A is my constant difference, right? And so that's equal to 2. So my A equals 1. So we've got A is 1, which is what we got the first time. So just double checking to make sure we got the same answer. All right, so my B now is going to be 3A plus B is what I need there. So I need 3 times 1, because we got 1, plus B equals to this number, which is 0. And so that's going to make my B equal to negative 3, which is what we've got. So that checks out. And then I have my A plus B, so I have 1 minus 3 plus C equals to 8. And so that'd be negative 2, but then it'll be plus 2. So my C is equal to 10. And once again, that's what we got. Okay? So as you can see, either method will give you the same formula. All right? So like I say, you can choose whichever one you feel most comfortable with, or whichever one you think is easier for you. By my judgment, it seems to be about the same amount of work. So I don't know if anyone is shorter or quicker than the other. All right? But anyway, these are the methods that you can use to come up with a formula for the nth term. And when you have a quadratic sequence like this, all right? And so I know sometimes when I was young and first doing these, the arithmetic ones you could get pretty easily, but when I was a young Coach Mason, like in 8th grade, 9th grade, I was trying to figure these out, and I couldn't figure it out, and it used to drive me nuts. Okay, the next one, find the sum. Okay, so again, we now have the type of problems where we're asked to find the sum of the quadratic sequences. And so here with this, again, we've also got two methods that we can use. We've got the formula that we could use. So I'll show you that method first. So it's going to be n over 6, and then just like with the last one, n is going to be the number of terms in the sum. So from 1 to 20, how many terms you got? You got 20 over. That's going to be now 6. And we can open up a set of parentheses, and let's see what else we got. 3D, remember D is the first difference, so that's going to be, I should probably write out the first few terms of the sequence then first so that I can get some of these differences. So if I plug 1 in here, let's see what we get. So that would be, there's a quick way to do this. Let's do it the quick way. Quick way would be to go into Desmos. We're just going to fire this in here real quick. 2x squared plus x minus 3. Go table. Yeah, that's a good way. But we probably want 3. Let's just go 4 and 5. All right, so there's my sequence right there. It's going to be 0, 7, 18, 33, 52. All right, so do that the fast way. From here, going to need the differences: 7, 11, 15, 19. Second difference, 4, 4, and 4. All right, so now this sequence should look familiar because that's the formula that we got from this sequence, right? So if I was smart, I would have just recognized, hey, we already did this formula, and looked up here, and my sequence is already written out for me. All right, but if it wasn't, throwing it into Desmos and getting the table is a quick way to get the sequence. All right. So now what we're looking for here, back to the formula. I'm looking for 3D, and remember D is the first difference. So that's going to be 3 times 7. So 7 is your first difference. So 3 times 7, 7's the first difference, times, what's the rest of it? N minus 1, right? N minus 1. And so what's your N? 20. And so remember, n is number of terms, so n is 20, and 20 minus 1 is 19. All right? Plus, what do we got next? N minus 1, which is 19, times n minus 2, which is 18, times C. Well, what's C? It's the constant difference, which is 4. Let's see. Yep, 4. And then plus, so we're almost there, plus AN. And what's A again? First term. So first term is 0. So 0 times 20. All right, so just got to make sure that you're plugging the right thing in for every part of the formula to make sure that you're in good shape there. All right, let's see, what else we got? We just need to go and simplify this down to what it should be. So that's going to be 20 over 6 times, you can just throw all this into the calculator at once. You get 1767, and then you can multiply that out, and you would see you got 5890. 5890. All right, so that's one method of doing it, plugging it in and doing the formula. The other method you should remember from the other sections. Remember, Desmos has a summation calculator on it, and so I'm just going to clear everything off here. And let's go to it. Function, miscellaneous, we got this. We're going from 1 to 20. and we've got 2n squared plus n plus, not plus, minus 3. And double checking, we did get the same answer, 5890. All right, so either method works. Okay, so one more that we want to do, we're finding the sum of the first 20 terms of this particular sequence. And so once again, notice that's one that we did here, right? And so I already know that this is the sequence for this particular formula. So I'm going to go ahead and write that in as 8, 8, 10, 14, 20. All right? So let's get the differences now. So that's 0, 2, 4, 6, 2, 2, 2. Okay, so let's plug in. It's going to be number of terms, 20 over 6. All right? Okay, so my first number is going to be 3 times this first difference, which is 0, times n minus 1, which is 19, plus n minus 1, which is 19, times n minus 2, which is 18, times c, which in this case constant difference is 2, and we'll close it off, plus. All right, so we need now the first term, which is 8 times the total number of terms. Make sure that's right. Yes. Which is 20. All right, we throw all this into the calculator here. We get 20 over 6. That whole parentheses right there is going to be 684. And then this is going to be plus 160 to the end of that. 2240 is what we should get when we add that up. We're going to use Desmos as a double check to make sure that we're doing this correctly. And so all I'm going to do really is just go in here and adjust the formula to what it should be. It's the same number of terms, 1 to 20. This is going to change to a minus 3. This one's going to change to a plus 10. And notice, oh, did I make a mistake? It looks like maybe I did. Let me double check myself here. 2440 is what we should have. And so I'm going to change this. I may have just written that in wrong. 2440. So this makes me now want to go double check what I did in the calculator. So we got 20 divided by 6, all right, equals to that, times 684 equals to that, plus 160. Yeah, it's going to be 2440. All right, so I wrote it wrong the first time, but it does match in both cases, whether you do the summation on the calculator or whether you do the summation on Desmos. All right, so that's it for this lesson. At this point, you're ready for your quiz.